want to do is create, solve for slope. Create, solve for slope. Okay, first thing we're going to look at is rate of change. Change over y, change over x. That's what the triangle's giving us. Then you want to use your x1, y1, x2, y2. Here's your equation, y2 minus y1, x2 minus x1. It's a 5 minus whatever your y1 is, negative 3. It's not 5 minus 3. It's going to be 5 minus a minus 3 because you're putting in a negative into an equation that already has a minus symbol. Over x2 minus x1. Solve, negative, negative, positive, 8 over 2, and that would produce the 4. Now this 4 represents what? It represents my slope, 4 over 1. Generally, we'll say this is a positive slope. What we like to do is look at, say, okay, let's go up and over when we're graphing. Okay, so we'll get to that once we get more towards the end. Now you're going to be asked to put into a point slope form. Okay, this helps you convert to a slope intercept. Alright, point slope form takes whatever change or factor you're going to have in with your y, your slope, and an x coordinate. Now you can use either coordinate to plug in and solve, and I'll show you that. Generally, I just like to use the x1, y1. Again, the formula has a subtraction symbol to start, and you're plugging in a negative. This negative does not account for this negative here. This doesn't say, okay, this is negative, so y minus 3, it's going to apply to the negative 3. You got to represent both. And then we have our slope, m, which we found here, 4 over 1. You can say, or write this just as a 4. That's okay, especially since you're going to have to, at some point, distribute, which is what you're doing here. And you get y plus 3 is equal to 4x. 4 times 0, 0, no change. Get y by itself, y is equal to 4x minus 3. Now this here represents your slope-intercept form because it's showing you your value in front of x, which is your m, and it's showing your value, which is a constant, which is your b, or your y-intercept. Now let's test and see what happens if we use a different coordinate, if we get the same slope-intercept form. So we'll say, okay, y minus 5 is equal to 4, x minus 2. Again, we distribute, y minus 5 is equal to 4x minus 8, add the 5, 4x minus 3, we have a match. Same thing. Now let's say they're asking you to graph, right? Which is what we were working on last week, coming up with our graph of our real life football application. And let's say we have our graph. You have 2 steps. First step is you're looking to plot your b, your y-intercept, which in this case is negative 3. So I'll go down to 1, 2, 3, and I'm plotting my negative 3. This is where negative 3 is on the y-axis. This is what is represented when x is 0. If my x is 0, I have no input. My output will be a negative 3. That'll be, like we could say, is a constant. Okay? Now here's my rate of change, my slope. 4 over 1. And basically what I'm trying to do here is I'm trying to go up, because this is positive, and then I like to go over. Okay, negative, it would be down. Negative, it would be down. So we go up, 1, 2, include the origin as a unit, 4, and over 1. Plot your point, and here you have a graph. You have a graph that you could work with. Now, what that allows you to do is input something for your x. Let's say I ask, you know, what happens when x is 2? Okay, x is your input. You could use your slope-intercept form. You can plug in for x and solve for y. Y is equal to 8 minus 3. Y is equal to 5. Y is equal to 5. Does that make sense? Well, let's see. If my x is 2, and I've gone up 1, 2, 3, 4, and over 1, I would be at a point at 2, 5 there. So when x is 2, yes, fits on my graph, my y is 5. What about when, squeeze it in here, when y is equal to a certain value? Let's say negative, well, if I have 3 here, I know, let's say negative 7. So I want to solve for x. I'll plug in negative 7 for x, or I'm sorry, for y, and I'll solve for x. Add 3, negative 4 is equal to 4x. Divide by 4, x is negative 1. Again, makes sense because here, if my x is negative 1, I've gone down 4, 1, 2, 3, 4 to a negative 7, and I've gone back 1, giving me a point of negative 1, negative 7. Okay, again, the reason we plot certain things to be our x-axis is because there are input, let's say amount of plays that you're running. The reason that we're inputting something for y is we're asking what is our input, giving a certain out. How many plays do we run in order to get a certain amount of yards? So that's when we plug in for y. Amir, you can kill the camera. Shouldn't be